it showed my neck.
It's the selfie trick, yeah. Oh, here we go. Ready?
3, 2.
Hello, and thank you for joining us for Aerospace Testing International's second virtual technology roundtable. I'm Ben Crampton, editor of Aerospace Testing International, and your host for today's roundtable, which is all about metrology and its use in aerospace production and development. Here with me today, I have two very knowledgeable experts from some of the leading companies in metrology. During the first half of our roundtable, they're going to discuss some of the latest advances and best practice case studies. Then, during the second half of the webinar, they will answer any questions you have about metrology. So please, do submit your questions during the first half an hour as they occur to you. We'll then publish and answer them in the second half. But first, I'd like to introduce our panel today. Randy Joyner, who is Senior Applications Engineer for Zeiss, and Christian Janko, who is General Manager of Bruker Alicona. Randall has worked for 42 years in aerospace. Before Zeiss, he worked at Pratt & Whitney and then Raytheon Technology, mainly in quality assurance, working with core organizations, suppliers, and partners. He has an extensive background in quality inspection and computerized inspection systems, such as vision systems, CMM, and structured light. He also mentors employees in metrology and programming, and has patents to his name that deal with advanced metrology developments. Secondly, Christian has been with Bruker Alicona since 2005. He is a graduate of the Graz University of Technology in Austria, where he studied electrical engineering and computer vision. His first role at Bruker Alicona was as a software engineer in the field of machine vision and as a project manager for the realization of industrial customized solutions. However, he soon changed to international sales, where he's been responsible for some key accounts, the strategic business development of European markets, and managing the global sales team. Since 2019, he has been the general manager of Bruker Alicona. Randall, would you like to give us some brief information about Zeiss and what you guys are up to or have been up to at the moment?
Yes, thank you. I'm part of the Zeiss International Aerospace team. We're focused on supporting our aerospace business and research and development of new technologies in support of all equipment that the Zeiss portfolio covers, from microscopy to CT to industrial metrology. And Zeiss has been here since the 1800s, and always, look into development of new technologies. And they're an independent business on their own, not beholden to anybody.
Okay, great. All right. Christian, do you want to give us some background on Bruker Alicona and tell us a little about yourself and the company, maybe what you've been up to?
Yeah. So, hello. Thanks you for the introduction, Ben. Alicona has developed a technology focus variation. So this is the history of Alicona, and we are parts of Bruker since 2018, December 2018. And what we, over the history of Alicona, found out is that the focus variation, this technology, we drove into the direction of metrology, perfectly fits also in the field of aerospace for different kind of dimensional measurements, surface measurements. And this is what we are driving at the moment. So we're having different kind of applications, and this is why I'm here, and I'm looking forward to have this really open podium discussion with you, and
great.
Looking forward to your questions.
Thanks, Christian. Yeah, so we'll have the first half where we talk in the roundtable, and then the second half where we'll have the Q&A session. But just before we start that, most people should be able to see just a short poll on their screens. Oh, hold on, I think I've got to click a button first. Start polling. Answer it if you feel like it. we'll have the results at the end. Just a little bit of fun. Maybe we'll do a couple of others during the session. Okay, so we'll start with a big question, really. I guess for you, Randall. What do you see as the major challenges in metrology within the aerospace industry right now? Are they significantly different to what they used to be? I mean,
there are very many challenges nowadays as new engine designs get advanced for new materials, higher temperatures, more efficiency. There are many challenges that include connectivity, software connectivity, and traceability of results. The technology changes with point clouds and multi-sensor approaches, and process challenges. Things like statistical process control automation, where you're only measuring features that are out of statistical control. Shop floor integration and connection. Process interruption control. Eliminating process interruptions. And these are things that we are addressing almost on a daily basis. We have teams working these various issues and helping customers work through those problems.
Okay. Hey, Christian, do you find the same kind of things? Are you finding the same kind of issues and challenges that your clients come to you with?
Yeah, I think I can fully agree with you, Randall, that these are the challenges. I think the most important thing is that the metrology equipment, in combination with the know-how of the company, is provided as a solution to the customer, because the requirements in metrology become higher and higher, because there are topics of increase of cost-effective engines, for example, in the aerospace, that reducing fuel consumption and so on. And this drives a lot the reduction of the tolerances of the parts, and also new features are coming up which become more and more into the focus of the customers. For example, there were cooling holes in engines which were not there before, and this requires new ways of metrology, of new types of solution, and these very complex features somehow need also be done or need to be measured in an easy way or in an automated way, so that they are be accepted by the customers and can be integrated in the production process of the customer. And I think this is the challenge, what we as metrology provider need to react on. And this is what we are working on. Yeah.
So that challenge of integration into a client's business, you see that as your key requirement.
Yes, I think the metrology is part of the production, and it's not as it was seen before in a separate metrology room. They are still there, and they will also remain also in the future. But for a lot of application, we need to bring the metrology solution directly in the production line or very next to it. And the interaction with this machine is, on one hand, could be fully automated with robot loading or whatever, or sensor integration, or it needs to be as simple to use, so that the metrology strategy and workflow is done by the machine itself and can be easily used by a worker.
Yeah, Randall, is that a key requirement for you guys as well? You know, that's driving the development of your technology is an ease of integration with other machines and within the production environment. Yeah.
Yes, that's a big focus for Zeiss. We have a big initiative to ensure, ease of use, integrations. Every day, we're talking about integrating machines onto the shop floor, automated loaded systems, integration directly in a production line with no interference. So that's ongoing. Recently, there was a CT system set up in a foundry that's fully automated with zero operator influence. So they load a part at the beginning of the process, and parts run through, get fully measured, and right on the production line with no human interaction.
Okay, so would you call integration with other elements of production and development and with other machines, would you call that your most requested feature? Or, I mean, what do they come to you and say, I need this, I need
Metrology on the shop floor really is requested the most for improved productivity, efficiency through automation. We work extensively to ensure that the machines run in any production environment with consideration of dirt and vibration and temperature. It's all considered in these machines that are being designed nowadays and delivered.
Yeah. Okay. Christian, do people come to you and say, I need more accuracy, I need more, I need it to be done faster, or, what's the most common request?
Maybe exactly in this combination.
That's the main question.
Always, I think it's key for us, and this is also a strategy question of Bruker Alicona. We discussed this. What should we do first? Is it speed? Is it accuracy? Whatever. I'm fully behind accuracy because you need the requirements become higher. So what we need is to have an accurate metrology solution, which is fast and integrated and robust in the production environment. So it's a little bit all of this. And it's depending on the applications. There are some applications which are more driven by having a fast measurement result than a really high accurate one. But the driver for us is accuracy and providing a robust solution and easy to use solution in the production environment. And this is, I think, the challenge. Because in the end, it comes always to these points, to all of them.
Yeah. Okay. Randall, you mentioned CT, computed tomography. I mean, where are you seeing? And I'll ask this question to both of you, but you, Randall, first. Where are you seeing CT being used, and is it replacing other technologies?
Yeah, I mean, we're seeing CT used extensively, and we're getting a lot of requests to look at the newer features, more advanced features, and that in the future we can actually see where CT might replace CMMs. Once the software development and we're doing testing now that of accuracies and capabilities to try and improve it to a point where you get a high-speed measurement, CT system that can measure, dimensional features with the normal Zeiss accuracy and reproducibility requirements. So it is being looked at as a future state single measuring system. I think you're muted, Ben.
Sorry, I'm working from home and my dog went a bit crazy. I'm sorry. There's no way of smoothing that over. How about you, Christian? Do you have anything to do with CT? I mean, where do you see it being used?
I see also CT as a coming really interesting metrology solution. So CT is more and more in metrology, and it's depending really on the application of where you use it, because with this you can see into the surface with or into the part itself, and with optical metrology or general CMMs, you see more the outer space, and you're faster in this case. But it's also, there will be a improvement and development that is becoming faster, and I don't see it as a replacement. It's not a, it's a complement, I would say, to the CMM. So I'm sure that all of these solutions will remain on the market, but they will maybe work closer together in the future.
I mean, so it's kind of more of another tool in the box, right? For engineers, right? Okay, right. Which brings me neatly to my next question, really. I mean, when does an application, when does it need more than one measurement method or sort of sensor to meet a requirement? I mean, how often is that the case? Is it very often, Randall? Or?
Oh yes, the aerospace parts have many processes and requirements, and it's that reason that Zeiss has the multi-application sensor system, or MAS system, that can mount on their machines. They can utilize the correct sensor for the right measurement needs. For example, we have a tactile probe with a feature called active scanning, or non-contact sensors, line scan sensors, surface finish sensors that all mount on the same machine. So the inspection can be done all on one machine, and also that helps condense the measurement reporting and measurement data collection. So that happens quite a lot for conventional type machines.
Okay, and how about you, Christian? Do you want to answer to that? Is that do you find yourselves you must advise customers when they're making purchases, and what's the kind of strategy there?
I'm more in favor of single sensor solutions on the measurement equipment, because having different kind of sensor solution on the same measurement environment is always a compromise between the technologies. When you change, for example, a multi-sensor system, you use a tactile probe and then you use an optical probe, then there is some compromise in there. And I think it's sure, you need sometimes different technologies, like this combination of CT with optical. But even there, I see the advantage if you have different solutions for it, different measurement equipments for this. And what we also discussed this in our strategy process, should we go in multi-sensor direction, but we clearly decide for not doing this and further develop our technology. So now we have, for example, developed the focus variation in the direction that we can measure vertical walls, which is called vertical focus probing, where you can really measure something from the top without tilting the part. And this opens and makes, for example, a tactile probe not needed. Okay.
Right. Okay.
And it depends on the application. For some application, it's maybe better to have you have a CT, or you have a probe when you need to measure very deep into a hole, whatever. But
yeah, I guess it does, as ever. It depends on each application specific needs, right? It's always different. But I mean, yeah, I think part of that question, part of the answer to that question is to do with data, right? And the amount of data that instrumentation and systems provide now is so much greater than it used to be. Do you think that makes the software as important as the hardware that you're supplying, Christian? Or do you want to take that first? I mean, how when you're developing equipment, I mean, is it as important? I mean, what kind of things do you look at now?
Yes, it is, and this is because as I mentioned also in the beginning, it's the ease of use of the machine, the acceptance for the user, because the measurements are somehow, and the feature becoming so complex because they're so small features and so on, that the machine needs to have some kind of intelligence and decide on the right measurement strategy. And therefore, for example, we are developing a software which is called MadMax, which is a software where the parameters are automatically measured based on the PMIs, the product manufacturing information.
Okay.
So this is key. It's automation and ease of use.
Yeah. Okay, but still some expertise required, right? There's, you
sure,
still need to know what you're doing. Yeah.
Sure.
Yeah.
It's important, and it has to be clear also when we are talking. And I think Randall, you can agree. We're all talking. Yeah, this is high accurate, and when you bring it into a rough environment, it has to be clear also for the customers that everything together, the environment, the part itself, reacts on the environment, and we have to have a whole picture of everything. And this, I think, is also a part of the company to make the end of the sales team to develop the solution with the customer.
Yeah.
Also the environment, where to place, and this kind of stuff.
Randall, do you agree with that? I guess when you're developing, software is one solution across different systems, or how does that work?
Yeah, our software supports multiple systems, multiple sensors. We also recently acquired GOM, and their software is also integrated, and we're starting to work with data, massive point clouds, in generating measurement plans. And it depends on the solution or the application, where we if we haven't seen a specific application before, we'll request a part and bring it into one of our labs worldwide for review, and then we can proceed from there as to what application is best for the process.
Yeah. Okay. And I guess that communication is something I wanted to talk about here, and interactivity during this webinar, because you have Industry 4.0 and smart manufacturing. Some people call it machine to machine, smart factories. Whatever you want to call it, really. It's all enabled by being able to connect machines faster. Has that been the biggest change? I don't know, in recent times that you've seen within metrology, that kind of connectivity and ability to connect machines, or what does it enable us to do now?
Well, for Zeiss, we fully support the Industry 4.0 and smart manufacturing initiatives.
Mm-hmm.
The actual challenge starts with the data. You get huge amounts of data generated by all the QA equipment, and that leads to questions to what to do with the data, how to handle it, how do you report, use it for making decisions and correcting, correlating the data. Zeiss's PyWeb software actually does a great job. It's enterprise level software, and this, I'm going to show a slide here that talks about our software packages, that are, we see it in two categories: quality intelligence software and metrology application software. And the interactivity through the metrology software exists. Again, like I said, we use our PyWeb software for looking at data. It's can be an enterprise level software where it receives data from anywhere within a manufacturing process around the world.
Mm-hmm.
And then, anybody in the, metrology office or anywhere along the line can open up a program and review data. They even have iPhone app for PyWeb to be able to review data. And on the shop floor side, we support integration on the shop floor, remote running and looking at running machines, remote review of right down into the controller level software where they can see if something's going wrong with the mechanics of the machine. So it's fully supported by Zeiss, and we're looking at applications all the time for statistical process control and things like that.
Okay, all right, sure. That's great, thanks. Christian, do you want to talk to that quickly? I mean, this idea about connectivity and connecting the machines together, and do you see it as bringing quality assurance closer to production? How has it influenced what you guys are doing?
It's definitely the case that we need interfaces to the different machine, this machine-to-machine communication. And this is something what we are looking into and what we are working with. We have our own department, which is called Customized Solution, where we directly connect our develop a special metrology environment and software which is customized. This is what we are doing, and beside of it also connecting to the environment of the customer. Mm-hmm. What I see for now is, and this I think is a little bit a missing link in this topic of Industry 4.0, is a standardization of interfaces, of real working together machine to machine. This is from the production machine up to the metrology equipment. There is no clear going through standard where all of us working together. And this, I think it's needed at some point that we develop this or work on this
and is that up to manufacturers to do that, or where should that be led from, do you think, that initiative?
I think there tries in different working groups to start depending on the industry. This we see. We are also strong in the cutting tooling industry. There are some initiatives for whatever combining metrology with grinding machines and so on. Mm-hmm. But even there, when it's a smaller application, there is no clear line between it. And we try to standardize something, but it's really hard because one company is doing this, and even when you're defining a QDAS interface, everyone is using in a little bit different way, and you need to customize.
Okay. Yeah.
And yes, so we are doing this. This could be some kind of improvement for all of us if we are maybe working stronger together.
Okay, great. I'm getting some good questions through. We'll just do a couple more questions in the roundtable like this, and then we'll go through some of the questions from the audience. We publish them as we're going, so if you're posting your question and not quite seeing it yet, you will see them, and when we deal with them in a moment. So if you have any questions, now's the time to get them in. There was a couple more things I wanted to talk about. First of all, I wanted to ask about robots and cobots, which obviously have their uses within metrology solutions. But I mean, where do you start when you are saying a robot would be better to do this? I mean, how much, or a cobot? I mean, where do you often use them in the solutions that you're delivering for customers? Are you using them more? Are people using them more these days? Randall, perhaps first, and then Christian.
Robots are used quite a bit for handling equipment, handling parts, loading them onto machines. The GOM product line uses robots to hold the sensor and actually, move parts within the sensors, so it can have an automated scanning of the part. Plus, they also integrate robots for loading and unloading of the parts. So I see it as a definite advantage to having robots in the product lines for moving parts, for loading parts, for measuring parts. It depends on the application, and it's really something that you need to look at.
Okay. How about you, Christian? What's your starting point with them with clients? Is it where do you begin to specify them?
It's depending a little bit on the application. I fully agree with Randall. What we are doing is we're using Cobots, as you see here, for example, on this slide, for loading parts on it. So it's the pick and place solution, which you can combine to nearly all of our products. Here it's with the micro CMM for when you have smaller parts. But we don't only use it for pick and place. We also use it in a way like this, that we really use a Cobot solution, and this product is called Cobots, Alicona Cobots, and this is used for measuring, for example, when you have really big parts and small features on it. For example, a disc in an engine, that you measure the edges on this disc to avoid cracks in the end. So it's a critical feature, and this is done here. Or for example, on the right hand side, the system is measuring the cases of an engine.
Okay, right. And you specify a lot of these in the aerospace sector. I mean, what are they used for?
So it's strongly used for edges. This is what our system is strongly used for, and this is for also automation then, because for example on a case they're measuring 500 critical edges, and this is done fully automatic. So there's no interaction needed by a user, and this saves a lot of money. Before, this was done manually.
Okay.
I think it's a big improvement, and this is strongly used, but it's also used. We have it for measurement of surface roughness or small radii on landing gears. So where the landing gear of whatever Airbus radii or whatever, very big parts, they where you need to bring the measurement equipment to the part and not the part to the measurement equipment. Yeah.
Okay, I understand. Great. Yeah. So my last question, and I'm gonna rush to it, was ties into the poll and also brings us full circle really back to where we started. And I wanted to ask about accuracy and the trade-off, with speed and flexibility. I mean, do you think we've moved on from repeatable accuracy as being the most important feature of measurement equipment to people really wanting other things such as flexibility and ease of integration and smaller, maybe even portable equipment instead of just valuing accuracy? I can see from the poll that the audience would disagree with me, that they like accuracy the best still, with flexibility coming a close second. I mean, do you guys want to comment on that? Does that surprise you, Randall? That's the result of the poll?
No, actually, accuracy is very much needed because you have requirements for reproducibility and accuracy based on tolerances of the parts that you're measuring. So one of the first and primary things when I was at Pratt Whitney was you had to have the correct equipment that reaches the correct accuracy, or you raise doubts about your measurement process. And then reproducing the numbers you're getting. So that's why one of the key things is when you're developing a process and testing it, you have to do a gauge R&R, ensure you're getting good and accurate results. The flexibility I can see is coming, second depending on what your measurement requirements are, because you have a lot of requirements on these parts for, surface finish and, things like, Christian was saying with, edges and size of features. So, I think one of the things we may have missed there is also speed, because, you need to be able to have your accuracy, flexibility with speed, because you need to meet your measurement, cycle times. Manufacturers don't want parts sitting, waiting to load onto a piece of measuring equipment, especially if it's integrated in the product line. It needs to be able to get fast, accurate results, in reproducible every time. So that's one of the critical things that, we look at when we're looking at measurement processes for new customers.
Christian, do the results of the poll surprise you at all, or do they echo what you'd expect, really?
No, I think it's exactly what I mentioned before. So it's I think, and this is what we are driving. Also, when you look to our product portfolio, it's definitely for me the accuracy, as Randall mentioned, because our customer need to develop accuracy and quality of the product, especially in aerospace part is there are a lot of security features in there, and it's not allowed that the engine is defect during the flight. Mm-hmm. So therefore it's first is for me the accuracy, and also this traceability back, so that you can be sure that the product and the feature is always measured in the same way, and it's traceable, and documented. Yeah. This is important, and by sure it's also always speed. It should take nearly no time. This would be the best for it. It's not always possible, and then you need to find the right solution and the trade-off with the customer between measurement speed, how much really needs to be measured, and but these measurements need to be accurate.
Yeah, metrology engineers like accuracy. I don't mean it to be the headline. It's not that much of a surprise, is it, really? It won't be the headline in the aerospace testing. Okay, let's move to the Q&A section, because it's the fun part, and the audience always ask better questions than me. So let's start with at the top there. Alessandro Civello, apologies if I get anyone's name wrong. My terrible British accent. He wants to know which solution you would recommend for very small radii measurement on blades and vanes, such as round edges, break edges, and fillet radii. Christian, you were just talking about that, weren't you? Right?
Yeah, I mean, this is what I showed before. These are the solutions we are having in the market. These are the Cobot solutions. This we have on a wide field. I think we, especially for the measurement of radii, we did a lot. And this started not in the aerospace industry, it started in the cutting tool industry. I would say we are the leading company in cutting edge measurement on tools, where we did a lot on R&D activities, where we worked a lot in working groups to standardize this kind of measurement. We're still working on it to do so. And we also did a lot of work in on the different radii in the aerospace industry, and implemented different standards in there. And there we see the solution with our sensors and the Cobots.
Okay. Randall, do you have an answer for that one, or is that all the Christian department?
Well, we do measure radiuses, radii, fillet radii, but you typically speaking will use our vision system for its smallest radii, because that's the easiest to pick it up. Mm-hmm. And yeah, that not super small, but we do have a lot of standards for measuring radiuses in our software package. So as long as we can, trace it with a probe, we can measure it.
Okay, great. I'll go on to the next one here from Sam Scullion. This is obviously a question for you, Randall, because it's about Zeiss. We would like to know if you've got products that would cover every step of the inspection process of a jet engine, and what type of parts require the most time to be inspected using automated solutions. This is quite a long question. Maybe just take those first two.
Yeah, well, there are things that are done on the jet engine parts, like, non-destructive testing that, for FPI, fluorescent penetrant, we're looking at possible solutions to be able to replace those. But, things like CT are quite advanced and can measure a lot of things. The other multi-sensor application solutions, the CMMs can measure a lot of those features.
Mm-hmm.
So, quite a bit of parts, the parts requirements. The long run jobs typically are big machine parts or machine parts like bladed rotors, where you need to measure, every airfoil, and flow paths, all the dimensional requirements around those airfoils that are on the disc part of the bladed rotors. So yeah, that tends to take the longest amount of time. So we're currently working on solutions to speed up those measurements, in a very reproducible and accurate way. So yes.
Mm-hmm.
So, and then things like our GOM solutions now are much more accurate and much more capable of measuring those same type of features.
Mm-hmm.
So it depends on requirements of the customer.
Mm-hmm.
And the GOM solution can measure very fast because it uses full field analysis.
Mm-hmm. Okay, great. Let's move on to the next one. Bastanel Arafin would like to know, and perhaps Christian, this is one for you because you just mentioned standards. He wants to ask about standards to do with metrology and aerospace testing. MIL and ICSS. He asks here. He points out. He's wondering what kind of standards you use for your machines, and whether there's a big difference between military and civil. You have customers in both, I presume, or?
Yes, we're having in both. We are coming strongly out of the ISO standard, as we are a European founded company, and the head of our R&D is part of the ISO committee and working on standards. Strongly in the field of surface roughness topic. There we are strongly working on these standards, and also in the field now of coordinate measurement machines. These are the ISO standards, but then we also use ASME standards for example, for the radii measurement in aerospace. And we're not, and then it's depending on the customer side that we follow different additional standards, but normally they are related to each other.
Yeah, sure.
So
it depends on the application, I guess. Right. Okay. I'm not sure who this one is most appropriate for. Perhaps you got whoever wants to jump in first. But it's from Jamie Jacquez, who wants to talk about advances in making 3D scanning. Are there any advances in making it easier when moving from point clouds to solid models?
So I since I've worked with those type of systems prior, I can say, GOM has done a lot of work in doing the full field scanning, generating, being able to scan two sides of the part with two different setups and having them merge together to create a fully generated faceted surface model. The thing is, to go from a faceted surface model to a solid model, you need, we're not in that field specifically. So we'll typically look at other software solutions that'll take the faceted surface and convert that into a solid, model of a surface model that can be used in CAD. So, but there are solutions. We have different scanners that can generate full field clouds, and then they can get generated into that faceted surface to be moved over. But we're not in the business of going from faceted surface to solid model.
Okay, sure. All right. Okay, let's move on to this one from Fabiano de Toledo Ferry. Christian, I think this is quite a nice question for you guys. He wants to know, can you show some applications of your solution capabilities? So let's make that a little bit more spicier. Let's say, when someone asks you what do you do? What do your machines do? What's the first application that you always tell them about?
Dimensional metrology in precision manufacturing.
Mm-hmm. And is that a specific study or?
And this is based on, maybe I can show this slide maybe, because this is what we doing at the moment strongly. What I mentioned before, this is this vertical focus probing, which looks like that this is some CT result, but we measure from the top into the hole with a single shot from this direction to measure it in this direction. And this is something which is, it's the newest development for us, and I think there's nothing similar on the market at the moment. But everything is all about the combination of geometrical form measurement, dimension measurement, and roughness. So this is this combination, what we are doing. And we try to do this, everything with one single sensor. And the reason for me is as well to make it easy for the customer, not to decide which sensor should I use now. Do I have different results than from the different technologies? So this way,
Okay. And just to be fair, let's ask Randall the same question. What application of your solution capabilities do you always say first? Do you always point to first, Randall?
Actually, we have such a broad portfolio, it's hard to say just one type of technology. Mm-hmm. We have a lot of advancements in microscopy, 2D, 3D X-ray systems, CT scanning, dimensional metrology, it really depends on where the manufacturer is and what type of measurements they're looking at as to which subject we would go to.
Okay, all right. Okay, well, let's move on to the next one then. You sound like you're hedging your bets there a little bit, but let's the next one, which is quite a pointed question as well, actually. Ravi Kumar would like to know what you consider the future of dimensional metrology to be. Is it contact, non-contact, X-ray, or something else completely? That's Christian. Do you want to take that one first, or?
My answer to this is yes. I think it's all of it.
Yeah.
I think there is no future of dimensional metrology. The dimensional metrology is a combination of all these technologies. It's not. It will be contact. It will a coordinate measurement machine, because when you have a big part, you need to it's the best solution for it. It's the fastest way of coming to a measurement result on it. And you need, for some applications, you need a non-contact solution, because, for example, with these holes, it's better to not touch it or get in there. So there is this the better solution. And for some applications, when you want to know how is how are the channels in the blade, for example, what we see there, you need to use an X-ray system, because you cannot measure it with a tactile or optical system from the outside. So it will be always a combination.
Sure. And how about you, Randall? You want to to name back one horse or hedge your bets with this?
Well, I did talk about, the future being CT measurements, measurement on a CT system. But, a big part of the future is also moving everything out to the shop floor and integrating it into the shop floor, which will actually, get out of the specialized rooms, just do your work in a single product line, not move parts over to the, Taj Mahal of measurement systems, unless they really need it to maintain their accuracy. But we're finding we can maintain our accuracy quite well with machines that are adapted for the shop floor. Even our CT systems are getting adapted for the temperature variations and being able to integrate on the shop floor.
Okay, great. All right, well, let's go to another question quickly from Jens Scharfenstein. I'll read through it. He wants to ask, do you see the integration of measuring systems in production in combination with better software as an accelerator for the transition from classical dimensional inspection to functional analysis of components and parts, either to support production or to decide on efficiency or life-critical behavior of parts in MRO? I'm gonna publish that. Does anybody want to take that? It's quite complex.
That is quite complex, and the issue here is, to build in the logic of an engineering group to say, what is the functional life cycle of the part? I mean, when I worked at Pratt Whitney, we had, full engineering teams that would evaluate, life limit, how well a part is doing, how well the part will project in the life cycle. So I don't see that as a function of the metrology organization. I see that more of an, integration of metrology results into the engineering system to where they can make those evaluations. So as long as we can, produce those measurements, generate them in a, systematic, consistent way where the engineering groups can review them and use them for that logical decision, that's where I see it going for us.
This I think I can fully agree with you, Randall. This is what I meant before, that metrology need be a part of the production process. And there is for me also this reviewing the production process, be critical, optimizing processes, and this needs to go hand in hand.
Okay, great. All right, well, I'm glad you guys were on that, and not me. It was complicated. Just the final couple of questions there. So last chance now. If anybody's got any questions remaining they want to pose, there's one here which is quite specific. So from Rob Engelhardt, what do you recommend for measuring a 13 mil sphere with less than 100 nm accuracy? Is that a trick question, or Randall is?
Zeiss actually has, and the name of the machine right now slips from my mind, but we have one of the most accurate CMMs in the world. 0.3 microns times L over 1,000 accuracy. So that can very easily reach to those accuracy levels. After that, I would assume something like Christian with his smaller systems might work well.
So for me would be the question first, what kind of material is it? Because what is it? Is it a glass sphere, or what is it? Yeah, because this is important when you make a optical measurement with it to see what kind of or what is the surface roughness of it, because you're saying you want to measure more accurate than 100 nanometers, then is important how rough is the surface, because otherwise the surface can already influence the measurement in this case, because it's maybe then more than 100 nanometers. I don't know. These are things which we have to look at it. It's a possibility for the micro CMM to have a look at it.
Okay. And what one last? He's put Rob. And I said,
Polish lithium. Okay.
Okay. All right. Does that change things or not?
We have to have a look on it. Yeah, we can measure very smooth surfaces as well.
All right.
But it's not an easy measurement.
It's not an easy measurement. Okay. Well, all right. Let's go to this last question then from Kelly Brisky. Sorry, Kelly. What is the quickest way to measure straightness on the shop floor? Who wants to say? That's a nice quick one there.
I go back to our shop floor equipment with the, all the various sensors. They're ready to measure any kind of part on the shop floor. They're being put on the shop floor every day. So, it's definitely an ability of all of our equipment that can go on the shop floor.
Okay.
Yeah, but the question is straightness. It's depending a little bit on what is the part about. Yeah, is it, how big is this, and what are the tolerances on it, and so on. Because
okay, well,
nice straightness, yes.
Two nice straight answers there to finish with that, which is nice. Okay, I mean that wraps it up for the Q&A session. I think wraps it up for the webinar there. I mean, all that's left for me to do really is to tell everyone that this roundtable will be available to watch again and download on the Aerospace Testing website. And also, of course, to thank the panel, Randall and Christian. Thank you so much for your time, guys. It was really appreciated and an interesting discussion. I appreciate it, as I'm sure the audience do as well. And to thank the audience as well, indeed, for their attendance and attention and inquisitive questions. So thank you again, and everybody stay safe, and yeah, great. See you next time.
Thank you very much.